Okay, so we are now on the 4th page of the 3rd quarter review, and we're going to do some composition. So the first one says f of g of -3. So that means you take that -3 and you put it into g. Whatever answer you get, you put that answer into f. So let's do g of -3 first. Here's g. It's negative something plus 4. And then you're going to substitute -3 for the x. So negative makes positive. 3 plus 4 is 7. So then we take this answer and we substitute it into f. f of 7 is something squared minus 3, and you put the 7 in there. So 7 squared is 49, and minus 3 is 46. Okay, the next one is f of g of x. So this time we're just going to put function g into function f. So start with your outside function, x squared minus 3, and instead of the x, put parentheses. So something squared minus 3. Now what you're going to put in those parentheses is function g. That's right here. So negative x plus 4. Now remember, when you square a binomial, you cannot just square each term. That doesn't work. You have to actually multiply the binomial by itself. When you square something, you're multiplying it by itself. Okay, then negative x times negative x is positive x squared. Negative x times 4. 4 times negative x. And 4 times 4. And then bring down the minus 3. Combine these like terms, so I get x squared minus 8x, and combine these like terms, and I get plus 13. Okay, the next one is g of f of x. So this time your outside function is g, which is right here, so it's negative something plus 4. And then you want to put into function g function f, which is x squared minus 3. So distribute the minus, you get negative x squared, and then negative makes plus 3. And then combine like terms. Okay. To simplify the rational equation, you need to factor. So I'm going to start by factoring the numerator. Numbers that multiply to negative 24 and add to 5. That would be positive 8 and now let's use the t. So t plus 8 and t minus 3. In the denominator, you have a common factor of t that you need to take out. So take out the t, and you're left with t minus 3. So your t minus 3's will cancel, and your numerator is t plus 8, and your denominator is just t. Alright, here we have the division of two fractions. So my numerator here, I need numbers that multiply to 30 and add to 11. So that would be 5 and 6. This denominator is 7 minus m, which you might not think of factoring, but if you look down here, you have m minus 7, and those are opposites. So what you could do is factor in negative 1 out of 7 minus n, which makes it negative 7 plus m. And negative 7 plus m is the same as m minus 7, so that might be useful. Alright, here I need two numbers that multiply to negative 20 and add to 1. So that would be m plus 5, m minus 4. And then over m minus 7. So when you have two fractions being divided, you can flip the second one and multiply. So I'm going to copy the top, m plus 5, m plus 6, and a negative 1 factored out. You can even switch the order here. Negative 7 plus m is the same as m minus 7, so you can see that they look the same here. Flip the second fraction, so here's your other m minus 7. And you have m plus 5 and m minus 4. So then m plus 5's cancel, m minus 7's cancel, and you have on top m plus 6, and on bottom you have negative 1 times m minus 4. Alright, in number 24, again we're going to be factoring. So up here, this is a difference of squares. You need to know your difference of squares pattern. If you have a squared minus b squared, it factors to a minus b times a plus b. So since 16 is the square of 4, this will be x minus 4x plus 4. Here we need the numbers that multiply to 24 and add to negative 10. And then here, we're going to change division to multiply, and we're going to flip. So that my numerator is now this, and I have a common factor of 3x, so I'm going to take that out. If I divide the first term by 3x, I'm left with x, and if I divide this by 3x, I'm left with minus 6. Alright, and then up here, I need numbers that multiply to negative 36 and add to negative 5. So negative 9 and positive 4. Okay, so then you're going to start looking for things to cancel. So x plus 4 and x plus 4, x minus 6 and x minus 6, and x minus 4 and x minus 4. So this is what we're left with, a numerator of 3x and a denominator of x minus 9. Alright, to add or to subtract, you need to have a common denominator. And there's nothing to factor in these denominators, so my common denominator is going to be x plus 5 times x minus 2. This fraction needs the x minus 2, so you need to multiply by x minus 2 in both numerator and denominator. And this fraction needs the x plus 5. Okay, so I'm going to distribute 5x times x gives me 5x squared, and 5x times minus 2 is minus 10x. Here I have a minus, so I'm going to bring that minus down, and remember that I'm subtracting everything in my answer. So 4x times x is 4x squared, 4x times 5 is 20x, 2 times x is 2x, and 2 times 5 is 10. Alright, so we're going to distribute that minus to everything. So I still have 5x squared minus 10x, and then I have minus 4x squared. And this combines to make 22x, and this minus distributes to that as well. So minus 22x, and the minus distributes to the 10, so it's minus 10. And still over x plus 5, x minus 2. Okay, so let's combine like terms. I still have 5x squared. Nope, I don't. I have to combine that with the minus 4x squared. So 5x squared minus 4x squared is x squared. Minus 10x minus 22x makes minus 32x, and minus 10, and then over x plus 5, x minus 2. Now you do want to check and see if your numerator factors, but there are no numbers that multiply to negative 10 and add to negative 32, so we should be done. Okay. To solve this equation, we need to get a common denominator of x plus 1. So this one's fine. 3x plus 2 over x plus 1 equals, this 2 needs to be multiplied by x plus 1 over x plus 1, and then this minus here. So I'm going to distribute the 2 to each of these, and then remember that once you have the same denominator in a rational equation, which you know because you have the equals sign, you can just deal with the numerators. So just this part. Okay, so I have 3x plus 2 equals, distributing this, I get 2x plus 1, and then I need to distribute the minus to each of these terms, so that would be minus 2x minus 3. Okay, 2x minus 2x, that's going to cancel. And so now I have 3x plus 2 equals 1 minus 3, which is negative 2. And then subtract 2 from both sides, I get 3x equals negative 4. And then x equals negative 4/3. Okay, that wasn't the answer I was expecting, so I'm going to go back and find my mistake. And it looks like it was right here. I forgot to distribute the 2 to the 1, so that would make a plus 2. So now the 2x still cancels out, but now I have 3x plus 2 equals 2 minus 3, which is negative 1. And subtracting 2 from both sides, you get 3x equals negative 3, and then dividing it, we get x equals negative 1. So then, you need to check and make sure that this number does not make your denominator 0. And if I plug it back in, negative 1 plus 1 is actually 0, which means this is an extraneous solution. And you cross it out, and your answer is actually no solution. Okay, in 27 we're going to find both the x and y intercepts and the vertical and horizontal asymptotes. So, x-intercepts. X-intercepts, you make your y 0. And you can write this whole fraction out if you want, but really it's just the numerator that you need. So x-intercepts will make your numerator 0, because 0 divided by something else is still going to be 0. So we solve this, and we subtract the 12. Negative 12 equals 2x, and divide by 2. So our x-intercept is negative 6. Which as a point will be negative 6, 0. Alright, y-intercept. You want to make your x 0. So you have y equals 2 times 0 plus 12 over 0 squared plus 3. So this gives you 12 over 3, which is 4. And as a point, that will be 0, 4. Alright, vertical asymptotes always make your denominator 0. So x squared plus 3 equals 0. Subtract the 3. X squared equals negative 3. And then when you do your plus or minus square root, plus or minus, you get an imaginary number, plus or minus I root 3. And vertical asymptotes cannot be imaginary, so you have no vertical asymptotes. Alright, and then for horizontal asymptotes, you need to consider the degree of the numerator and the denominator. So let's go back to the equation. The degree of the numerator is 1, because that's the largest exponent. The degree of the denominator is 2, because that's the largest exponent. So the bottom has a bigger degree. So when that happens, your horizontal asymptote is always y equals 0. Okay, and that is the end of your unit, not your unit, but your quarter 3 review.